welcome to our third and the last meetup about AI management. And today I want to present Karolina Griciūnė, data science team lead from Danske Bank. And today Karolina talks about art in data science. So give applause and ready stage first.
Good evening, everyone. I'll just get to some practicalities here. That's fine, I can run in this way. Just go take your seat and have fun. Okay, so first of all, I'm very glad to be here physically. It's been like thousands of years since I left my village because I live a bit outside the center. So it's a huge celebration for me to come here to the city and meet all of you. I'm very also glad that you came to listen to me. I hope I will tell something interesting for you, and if not, please raise your concerns, comments, and questions. And out of curiosity, how many of you are data scientists, tech people? And how many of you are leads, project managers, and okay. So we are going to, 2 in 1, 3 in 1. Cool. Okay, so I studied physics, and then I studied computing physics and modeling. I did a bit of modeling while I was studying, and then I started working in a couple of organizations as a data analyst, and then I really wanted to do data science because data science was just emerging in the market, and then I joined the advanced analytics team where we were doing some crazy things in the bank. So first models we started in the bank was NLP, neural nets, and note here for you is that I'm not talking about the problems we're trying to solve. I'm talking about algorithms that we were trying to apply to what we wanted to create. Even though these were very, good times for me, because everyone saw us as a very, clever people who are going through organization, telling people how to innovate, and we were, those people who were bringing the light to organization. But after half a year, I got into real frustration because I realized that I'm not succeeding here. And even though I had a lot of lines of code and codes technically were working and models were technically working, and I managed to build some quite advanced models, but no one was using those models. And then I took it personally. Oh yeah, I took it very personally. So then I started digging. Okay, so what is happening? What's wrong with me? And around that time, because I was kind of on that time, I was actually in the board of banks, data science leads or something like that. So basically there was a board of all European banks and one data scientist representing the bank. So I was in that board. And then, we were kind of talking about modeling, and everyone were talking about crazy things that they are doing. And then I was out in big conferences, and I noticed that during conferences, when someone was presenting, really advanced models, there was only one hand in the audience. It doesn't matter what kind of country, whether UK, Germany, or whatever, raising the hand and asking the question. So, is it in production? And then there was a silence usually, and then the speaker would say, well, almost. We are like the final touches on the model, and it will be in the production. And then I kind of felt that these two are related. And then the third part was that when I was reading blog posts and listening to podcasts of data scientists who are working in US, because they had a beta ahead in time. So they were talking, that was the hype of AI, there was a hype of all the algorithms, and then people faced the reality that, nothing is happening. And according to Harvard Business Review, so in 2012, I believe there was this famous article that data scientists been named as sexiest role in the 21st century. And then a couple years afterwards, they started presenting statistics that around 93% of machine learning models and not making into production. And then they started writing about communication. And then I thought, okay, so infrastructure, IT infrastructure was there, since long time ago. AI algorithms, ML algorithms, been there since 1950s. We as human beings, we are here for quite a long time. So what is wrong here? Why we are not achieving here? So since 2016, 17, it became interest in mine how to deliver in data science. And then I really wanted to work in closer to our users of our models. And then I got an opportunity to move to Copenhagen and work in frontline in business banking and work on data science strategy for business banking. So basically then I started doing not models, but thinking how to combine all the models and how to make it useful for someone. And in Copenhagen I had very different experience because previous we were doing crazy stuff, we were trying out a lot of things and we were not succeeding. And when I moved to Copenhagen I had no other choice but to deliver. And no one cared like how I'm delivering, and no one cared about algorithms because no one knew. I was the only data scientist sitting on the floor there. But I had to deliver, and timelines that I was given were tough. So I had eye-opening experience back then, and actually I combined those two experiences. And when I wanted to progress in my career, I met someone from Treasury Department. And if you are wondering what Treasury Department are doing, so I would say imagine guys who are coming to work with three-part suits. So this is how Treasury Department looks like. So I got invited to create a data scientist team and start over data science area or whatever we are going to do there in Treasury, and now we expanded all over to CFO area, so we are taking care of finances. What I got there, I got an opportunity to try out all the things and total freedom to do whatever I imagined there, of course with the responsibility. So I know that David spoiled a bit the second slide, but what I wanted to share, so usually I'm having a question. Think of the oldest, so I will act that you didn't see. You might say the right answer who were before me here. So think of the oldest known mathematical model. Regression. Okay, that's quite old. Agreed.
What do you mean by model?
Well, let's say when some math were used in order to predict what is happening, what will happen in the future, and to explain what is happening currently, in the world for human beings. And who saw, just shout it out, because I have a lot of slides. You will be tired soon, so just shout it out, the right answer. Seriously, no one saw? Okay, so my point here is that I was thinking about that, and I'm biased here because I studied astrophysics. But the first known mathematical model, and I'm not happy with the history in general because this is how I Googled and I tried to confirm this knowledge, but the oldest known, I haven't been there by the way, so I cannot confirm you that, but basically this model is absolutely wrong, and this model says two things. That the Earth is at the center and all the bodies are moving around in circular motions. This model is based on two wrong assumptions, although this model survived in production for over 19 centuries. 19 centuries. And it was approved by regulators. It was approved by church. And when someone was trying to update that model, they wanted to kill that person, and I'm talking about Galileo, yeah? So when someone is telling to me that, modeling is hard, hey guys, it's not anymore. So I wanted to tell, especially because someone said that this is going to be, executives listening here, not data scientists. So when we are talking about modeling, And when we are thinking that, well, it's totally new, all those algorithms. No, this is not totally new. And I think that if we would get back and think about, us as human beings and our needs to predict what is happening in the future, and first of all to understand what is happening, around us, then we are going to be more successful in modeling. So I prepared a game for you, a board game for tonight, and this game is called Wood AI, From Idea to Production. And as we know in all games, we have to have some rules. And some of us, we like to read rules, and some of us, we hate reading rules. I hate board games in general. So, but there is one rule that we have to respect. It's the minimum amount of players that can play. So, minimum amount of players that can play this game, I would say 3. And I'm talking about, I'm calling data science modeling, you can call it AI, ML, it's a matter of definition here. So first of all, you need a person who would understand math, statistics, and would be able to program. Second of all, you need someone, I call it a subject matter expert, you need someone who understands the problem and the context of the problem. And thirdly, you need someone who will be able to make decisions and who will be comfortable taking tough decisions during the time. If you are working on, let's say, AI project, you need someone who would tell you, well, sorry, it's not the best move here, can we switch? Or if someone is arguing about things that, are not going well, so someone should say, okay, we are stopping here, let's say we are excluding that part of the data, leaving it there, we are moving here. So someone should take that responsibility. And by the way, I like to say that decision maker should be that person who is interested into succeeding this project. So there should be a stake. Yes, Dala.
So
I feel like a teacher now.
And the decision maker could not be the same person.
It's a conflict of needs, because when you are in the problem, and when this problem, okay, it can be. I'm thinking it can be, because I just remembered one situation when we did like that, and it was the same person. But usually SME, because it requires a lot of time. Usually SME is someone who should be in the project, for most of the time and be there together with the data scientists, data engineers, machine learning scientists, research scientists, whatever you call this in your organization. So they have to be and work together. Decision maker can be someone who is stepping in and saying, okay, what's cooking? Okay, I see you're not progressing well. Okay, we have to make decisions. We have option A, B, C. Let's go with B, and getting out again. Makes sense? Doesn't make sense?
Yeah.
Okay. These are my rules, so you can challenge them. Okay, so the first thing we have to think of is the problem. And I like to say it should always start with the problem. And trust me, this should be your face or data scientist face when you are starting the project. Otherwise, this might be someone's face when the project ends. I'm not saying that innovating is bad and just thinking about the problem and trying to do something for someone is bad. But I'm saying that if you don't see a problem at the moment, look for the problem. Even you are innovating, you have to have a target, because the process is quite complicated. You have to set up together all different people to work together, yeah. And then if you don't have a problem and target, this is going to be even more difficult. And actually, I haven't seen any case in my situation where, in my experience, where someone started without clear goal and they succeeded. If you know the example, please tell, because then I will change my slides for the next time. Then if we have a problem, we have to understand the type of the problem. And yeah, here I prepared again for executives and someone who is not working as data scientist, but basically what I wanted to say here is that type of the problem. There are problems that we know what is the answer. Those are called supervised learning problems. That we have a data set, we have what we can call truth, these are labels, and we have historical data, and then we can clearly define what is our target. It's called target function, but yeah, this is quite a general word, target. So you have to know the target of your problem if there is a target. There might be that you will face unsupervised learning problem where you just have a data and you don't know what is happening with this data, and you just want to look around and you want to get to know the data. You want to get to know the shape of the data. And this example is quite ironic because who is working as data scientist, you know that trash in, trash out. You cannot put trash data into the model and expect something good. So that's why I put trash in and sorted trash out. This is probably the goal of a data scientist, right? In general, I'm using unsupervised learning when we are starting the project and we want to explore the data, when we are wondering, I wonder what if this data would do with, I don't know, something. I wonder if those customers are, you know, into 3 groups or 4 groups. So types of problems and moving on into central station. So if this game is about traveling, we are arriving to a central station to pick our vehicle. So if we are traveling somewhere and if you have a friend who would come to you and ask, hey, would you like to go with me? And then naturally you would ask, okay, so where are we going? For how long? So I would say the same as with projects, data-driven product development projects. I want to be as broad as possible here. When we are picking tools, we have to be mindful about not only tools itself, but the infrastructure surrounding those tools. Because tools might help us, but also tools might drag us down. And I'm not suggesting to classify that if you have this type of problem, you have to use this tool. No, I want to unlike those edge cases when I see some Excel files that, you know, the name is final version 1, version 2, version 3, then 10 updates, and it takes 10 minutes to open the file. It's red flag, yeah? And vice versa. When someone is asking, yeah, could you please give me a simple report what is happening with those customers, let's say. And then they are opening, I don't know, SQL, putting data out of SQL into Hadoop, then doing some sort of, you know, simple calculations that they can do in SQL and putting that. Fine, result is good, but it just takes much more time to do that. So, you know, pick, like if you are going out for 10 kilometers, you are not picking a plane. Because, well, we don't have infrastructure for that. And if you are going thousands of miles, you are not picking bike. There are people who are doing that, but they are not doing this for, you know, work purposes. They are doing that for fun. Okay, then the next one, and there is a question for you. So we know the problem, we know the type of the problem, we know what kind of tools can we use. Can we look into data and can we, you know, pick the algorithm and can we finally, you know, have fun? Yes, no. This is simple.
Yes. No.
Yes.
No.
No. So yes or no?
No. No. No and yes.
You're a tough audience. Okay. In my opinion, no. And I have one rule that I love, and I apply this rule. I apply this rule everywhere. That's why in our apartment we don't have lightnings. I don't know, I forgot the word, but yeah, that's why I'm not finishing anything. So this rule is called good enough. How I developed that rule. It happened so that I left physics quite early, and my group mates went to PhD and finished that. And then one by one, they started working with me. And then I realized that when people are coming from academia, not only them, but in general, data scientists, they love doing a good job. And in academia, we have this thing that if you are increasing the accuracy of the model from 92 to 94, that might be a paper. And you might you might be out with a paper and you might be famous because of this paper. But in the business, the story is different. Yes?
I would argue that's a very strong generalization of academia.
Yes. Yes.
If you come from field of statistics, the whole problem is there is defining the right problem and what you measure. And yes, there are loads of papers of machine learning where all they care for is sort of results. That's unfortunate for them.
Yes, you're right. I haven't spent much time in academia, so I might get back and learn and then get back here again.
Yeah.
But yes.
I think it's more about attitude, about getting things done, not dragging it forever.
Well, potentially. Well, I mean, yes, there is this problem in academia. But
Yes, so perfect. And the fact that we all fall in love with what we do. And when we have a model, and when we spend a lot of time on the model, and when we need to let go out this model, it hurts. Even though we see, a lot of things that we can improve immediately, and when someone is coming to us and saying, hey, give it to me. So as for stakeholders or someone who is managing teams of data scientists, you have to take it out on time, but do it carefully. You have to be aware that it hurts for those people to let it go of the model. Yeah. And then there is another story that when you develop a model and you see the model and you basically having a feeling that I'm not sure if someone will use this model because business environment might change. I don't know, the model accuracy is not good enough, or someone might not want to use this model. Then that's a red flag for don't launch it. So basically what I'm saying here that before looking into data, you have to sit all team together and define good enough criteria. You can call it whatever you want. I love this good enough. But you have to define how the model should look like in order for it to launch. It shouldn't be, perfect, because if it will be perfect, then it will take for business too long to wait. Start with version 1, launch version 1, and then work on improvements, rather than ask business to wait for 2 years for you to improve on 2% of the accuracy, and vice versa. If you see that the model is not, bringing a lot of value, then you can wait, or you can accept the fact that not everything that you develop is worth launching, and it's not your fault. Don't take it personally. Okay, then the next topic is bias. This one is a tough one. The fact that we are all biased when we are looking into data as well, because everything that we see in the world we see through our eyes of experience, and it's quite unique. And it's absolutely natural to be biased, but we have to deal with it somehow. And additional thing about bias and numbers is that when we are talking about something that is far away, I'm getting back to astrophysics, then we kind of have a feeling that it's only approximation of the thing that we are trying to model. But when we are looking into numbers and we see, some trends and graphs, then we sort of having illusion that, I know more about this because I can, go and touch those numbers. And if it's especially related to, some customer, purchases that you can go and touch, then you are more confident, or I am more confident when I'm modeling things like that. But if I'm switching this question, which one is easier to model, human behavior or something that is defined by physics of law, then I have a strong preference here, and it's not laws of physics. How to deal with bias? So I'm going here. It's avoiding or two things. Don't look into data too early. Let yourself to think about the problem, analyze the problem, and then let yourself wonder how the final solution should look like. And don't jump into solution mode too early. And this is the thing I'm doing in my team, and my team won't let me lie because they're here. It's very important to avoid getting into bias, because I don't know if you're working with data, you might feel the same. When I'm scrolling through the data, when I'm exploring data, I sometimes feel, oh, this looks good. And then, I'm doing this unconsciously. And then I have a feeling, and biochemistry works in my body here. I feel good, but basically, probably I don't remember that 3 years ago I had a problem and I solved that problem, and just because I saw the same trend. And I don't remember the fact that I solved this problem, by looking into the same shape. But I remember the feeling. It's actually not me, it's my body remembers that feeling. So please be aware of that, and if you will follow those rules, I'm sure we all will be fine. And then finally, we are looking into data. And for data scientists, there would be another story about the data, that you have to fall in love with your data, that you have to understand the data. And for managers, executives, and stakeholders, you have to know the history of your data, all the migrations, where it came from, and then what's the way from for the data point, let's say from the start where it's been registered to the system that you are seeing the data. It's very important because data has history, and sometimes data is old, and if we are working with modeling, like we like to work with old data, we love to have full history of data, and we all know that we have to respect elders. So it's the same with data. And don't trust too much the data, and if you will record the history of the data, and you will take this into consideration when you're modeling that, then you will leave some good things for future generations. Because when you're letting out your model to the world, then another story begins, but we'll talk about it later. Okay, question for you, data scientists. How many data sets should we have?
Enough.
1. Who is more?
Partitions or data sets?
Data sets.
There is no upper limit?
There is an upper limit.
You will set the limit, soon. 2?
I would say 2 is a minimum.
2 is a minimum.
As much as they're needed to answer the problem that you define.
I love your answer.
But not one more.
But who's going for free?
Usually.
Free. And who's going for 4?
Nested cross-call, would go for 4.
Remember, I prepared this presentation for executives. So, I would say 4, and it's not me. I copied from the literature. This one, 4 data sets, and I added a small gift from me, development sample gift. So first raw data, then split exploratory data, test data, training data, validation data. I will talk about this in a minute, and development sample. If you're working on model, and please take a snapshot, it will be like a picture from your team, when you are working all together and when you are developing model, and when something will get wrong, you will have this nice picture and you will be able to get back to this and everyone will thank you. So development sample, I know that not for all models this will be applicable, but if this applicable, think about development sample and saving it for future generations. Okay, quickly, exploratory data. Go crazy, plot everything, look for trends, outliers, features. Test data, forget it. Training data and validation data, check your assumptions, run through the model, get results, and compare. This is quite standard, right? Agree? I wish I made mistake in this slide. Okay, moving forward. Algorithms. Sorry if you heard that. This is my favorite slide. Yeah?
Could we go back to the previous slide?
Yes.
One more about the.
Yep.
So, what do you think about the later problems if we just split and we'll have the data leakage, or basically just our test set would overlap by some category, patient, or some customer, and we will have problems later.
Test data.
If we just shuffle the subset and the snapshot, we still might have the data leakage because of some parameter or the category or some time dependency, and it might not be the real test data.
Yes, that's possible, but I think that you would find this thing while you are doing this circle of, training, validation, and then, when you are doing this. And if during this time you see that, you have data which is like really fragmented, for example, am I getting right that you're talking about really fragmented data and the fact that the chance that it might get into test data? Yes, if you're seeing that here, definitely you have to get back and then, apply those rules. Yeah, that's a very good one. Okay, algorithms. True story. My grandfather asked me once, so what do you do in the bank? What is like data science in general and in the bank? And then my grandfather is a writer, and then I had to come up with something, he would be happy with. So I told that, data scientists are like doctors in the organization, because everyone is coming to them with the problems. And then data scientists, they have to listen carefully, and then they have to understand the problem, they have to diagnose the problem, and when they diagnose the problem, they have to write a code, a recipe, and then they have to suggest, the solution and heal their patients, business stakeholders. And data scientists, they have to listen carefully, and especially about the symptoms, because those symptoms might be primary, might be secondary, and I don't know how many times when someone from business came to me saying, oh, I have a problem, I need a model there, and they went out with the answer, you don't have a problem, you don't need a model. So that's the first thing, that's my null hypothesis, you don't need a model. And then if we are continuing with this, then I would say that algorithms are like pills, and good data scientist has to understand what kind of pills are needed for that particular problem. So basically matching. This is the problem, this is the recipe. Because I'd like to say that machine learning algorithms are like antibiotics. They are very effective, but they are not meant for all the problems in the world. And by the way, recently I've started enjoying looking out for very old algorithms, classical mathematical algorithms, and trying those onto modeling, onto our problems, and these work quite well, I would say. Overall, heuristics are very hard to beat. So don't forget that. So don't go into the most complex, and actually I deleted that slide, but I had the question for you. Which algorithm should you go first? I heard regression?
No algorithm.
No algorithm. Good. I like your answers. Yeah. Sorry, I haven't heard. Random forest. Yeah. Distribution.
But it depends on the problem that you are solving.
Yes.
The data structure.
Yes. And you know why I deleted that slide? Because my answer was the simplest algorithm. But then I realized that it depends on the problem. Okay, so we have a problem, we have tools, we have data, we defined criteria of good enough. Can we say that we finished the model? Again, yes, no, it's simple.
No.
No, okay, what's next? Deploy. Production, deploy. Monitor of data. Okay. My dear student who started data science 3 months ago. 4, sorry. Okay. There's a good thing. I have an ad here. It's not paid ad. Prototyping at its best. I fell in love 5 years ago with one book. It's called Design Sprint. It's how to develop things in 5 days and test fast. So basically, we are before COVID. We started this project like that. 5 days together with business, sitting, defining the problem. First 3 days for business problem. 1 day to build a model. Think about that. And 5th day for testing. And then after 5 days, we are talking to our business stakeholders and saying, cool, is it worth to launch or not? So I recommend this book. Okay, so what's coming next? Validation. And when I think about validation, I see it like this. So it's about fitting, and actually when I showed the slide to my team, they laughed because they see this as, they see it very differently. So I will explain what I want to say, and then I will explain what they saw. So what I want to explain that when we build model, I told you that we fall in love with it. And we want this model to be good and to be a good fit for business or our stakeholders so badly that we might do crazy things for that. Remember Cinderella's story, what they did. So please don't cut your legs in order to prepare the best model for you. You can go back, it's fine. It's only validation stage. You didn't launch the model, it's not deployed. It's fine to test it out. And when I showed the slide to my team, so then they thought that this is our team and this is validation, yeah? Or vice versa. I don't know. You tell. Because like we have separate team who is validating our models, and we really want to be best for them. Okay, another thing about validation, and this is a machine learning thing. And when we are validating, when we are not, deploying things yet, we have to think about optimum learning, because let's say neural networks, they are very good to fit, and they are very good to overfit. So imagine students who are preparing for the exam, and one student would be, I'm bored, 5 is good enough for me. So this is the student in the middle. 5 is good enough for me, and then they are going out for beer, and then next day they're getting 4, failed. Then there is another student who is trying to memorize everything, yeah? And if you try to memorize everything, you can be extremely good at that. But if you are studying, let's say, I know for sure that if I would try to do this in physics, I would fail. So if you are trying to memorize everything, you are so good on those cases that you did. But when you are getting exercise during the exam, you simply fail because you don't know, you haven't seen this exercise, you don't know how to do it, how to complete it, yeah? So 2 bad cases. And I know that for data scientists, we have a very, very, very bad feeling when our model is, out of, fit, and when it provides us extremely good accuracy. So try to look for optimal results. And in general, your model is like, parenting. You have to try it out in all different scenarios and all different modes. Because as human beings, we have loving parents. And when we are kids, and when we are going out, our parents are, repeating to us thousands of times, this is a dog. And then we're saying, now, no, this is not a cat, this is a dog. And when we know what's the dog, then we are going to the cat, yeah? And then when we know what's the cat, then our parents are taking us to the zoo, and then we learn what's an elephant, what's a giraffe, yeah? And then we know, we are expanding. And at one stage, when we know all the animals, and we know that putting hands on fire is dangerous, we are let out of the world, to the world, yeah? So it's the same with the models. And if you fail validation, and if you don't feel comfortable during validation, it's the perfect time to get back, and it's absolutely fine to get back. And then regarding test data that we talked about. When we are done with all those things, when we are done with validation, so again, validation is the process that you can go further, you can go back, you can change anything. Test, you can use it once. It's basically your exam. Fail, not fail, because this is the data that you were not using for training your model, for validation. This is absolutely new data. That's why I think we need 4 data sets. And then documentation. Where are your smiles? So documentation. I won't spend a lot of time here, but documentation, when you are completing the model, you did a fun part, and then you're sitting to your computer and you say, okay, now I need to do documentation. And then for 1 week you're doing documentation, you hate it, and then you're jumping to another model, right? That's fun. This is how we do it, right?
Sure.
Okay, so I would say that, writing documentation after you've done the model is something that, you want to show up. I'm not saying anything bad about you, but, to do documentation after you're done is just, I did this model. This model is so good. I use this algorithm. This algorithm provides, accuracy of 87%. But you are not mentioning that, it's providing the accuracy of 87%, but before that you spent 5 months because the accuracy was 60%, yeah? But actually, when you or someone else will come and look at this model, when this model will, become important, or this model will enter the phase it's called recalibration, no one will thank you for such documentation. People will thank you for the documentation where you will write, dear diary, today I had an extremely bad day because my model is not working. My model is totally, And then I got a lot of questions from business. And then I don't know how to answer these questions. And then we argued with business. And then I told that I want to go this way, and business wanted to go another way. And then we agreed to exclude this data because we think it's not good enough. Yeah? And then when 2 years later someone will come to you and say that, can we include this data now because we think it's good? And if you would have this type of documentation, you wouldn't mention that fact. And here, you would mention this fact. So think of documentation as a diary and write as you are developing the model. And then, final thing is the launch. Test, input data, data pipelines, controls, how they're working together, how they're working separately, if you are responsible for that, or as stakeholder, test that those elements exist and no one is running, pressing enter to run the model each month and then thanks God not each day. But think about what if. Think about all the worst things that might happen to your model. All the wrong data. What if I'm going to send to senior management data and they will lose 2 millions of my bad model, yeah? So basically the outcome should be, if this is happening, I'm turning off model. If this is happening, I'm putting some default values. If this is happening, I'm sending out automatically emails to all stakeholders. If this is happening, if customers' behavior is shifting, by the way, we do send emails to our stakeholders because we have, this is a true story. We have thresholds that business set, and we say that if, and they say, by the way, this is a fun exercise, so you can do that. We developed a system, author is here, that automatically checks what is happening with the models and then informs, let's say, us if that would be technical things. But then we ask business, so what would you do? Okay, what's the threshold for you to be informed? They set the thresholds. And then we told that, yeah, if, let's say, money would be up high, you will get emails. And then, yeah, that's cool, we are looking for that. And then 2 weeks later, they're calling me, my manager is calling me saying, can you turn off those emails? But that's a very good thing because they then understand how the model works. And that model is like, it's a creation that lives their own life, and that's fine to have, you know, and you cannot predict all the things that is happening. Remember, as I told that us as a child, we were, you know, more predictable, or vice versa. But when we are going out, we are meeting new people and we are getting into new situations. So it's the same with the model. So think about all what-if situations and document them, and define them. Then someone mentioned monitoring. I don't have much to say about monitoring apart the fact that it must be in place. And to end with this story is that if you're launching a model, you are letting go of something that will belong to you unless you will leave the company. Yeah? So think carefully what you are launching, and remember that good enough criteria, because if you are launching something that will create you more problems, then before launching, think about this slide, because you will have to take care of this model. So it's like, I love dogs, I want to get second dog, and my husband doesn't allow me to have a second dog. So I really want, but that's the thing, I'm thinking about, you know, all the good things about dog, and he's thinking that, you know, about the things that we actually need to do with the dog because we have one dog. So it's the same with the model. If you have one, if you have two, but think what if you will have 10 models? Then do you have, you know, is your team big enough? Will you get, you know, more budget for that? And of course, this is the question, first of all, for automation. But first of all, everything should be automated. But recalibration is needed anyway. So I'm leaving you with this slide. And I really wish you to have fun playing this game. Any questions? Yeah.
I have a question. At which point there is experimentation?
Algorithms?
No, I mean, okay, you've applied to test data, right? Your model, you got the performance, and you're ready to go into deployment. And your model is usually part of a complicated decision process.
Yes.
So you want to test how it is with the model and without the model.
Yes. You know, this game is just version 1. I would say it's somewhere here. And between the production system. Have I answered your question? No.
No, I just wonder if we understand experimentation the same way.
You're talking about those elements that you are kind of running the model in the soft production. Would it be the same?
Yeah, it's A/B test. You deploy it in production and you see what happens with the status quo.
Yes, I would say here, but then I would need actually another step in this game, and you're right here. Yeah.
Yeah, but the part of monitoring, recalibration, and basically the whole cycle of adjusting of the drift of the model, probably that one would be the place.
I guess it's before production. It should be before production.
To A/B test, you would want it to be in production and have the monitoring.
Not all models they need to. Not all models need A/B testing. So that's the first thing. I would say it should go during validation. Look, this is something that we have. It's called soft production. So basically, we are trying. Okay, you know how business are calling soft production. I really love this. My business I call it material under the table. So we have that. So this is basically when you run the model, and but then no one is kind of using results, but they are there, and you know. So I would say there is a good place to try it out.
And a follow-up question: you said that not all models need to be tested, A/B tested, and what is the criteria for selecting which model fits that and does not fit?
Which models they need A/B testing? For example, in our team we are not doing A/B testing. I'm looking into faces because we are working on sort of more research models that we are looking into how changes in markets might change customer behavior. So finance environment, and when we are developing model, usually we are kind of doing development process. Because it's quite, I don't want to say it's quite long because in our environment we are doing this fast, but let's say half a year or a year if it's a bigger model. So we are kind of going through validation phases, and we have to sometimes go talk to financial regulators to present this model. So we're kind of testing it during the way. So this A/B testing, we are kind of launching models that are, sometimes we need to run those monthly. We set up to run those monthly, sometimes daily, but humans' behavior don't change that fast. So if we are certain about that result, and we know that, so let's say I did a model and I checked that human behavior shifted a bit in 10 years. And then we were talking with business, do we need to build 2 models or 1 model because of this shift? And then we decided, okay, for version 1 we have 1 model. So it's about the process.
Now that you've given the context, I have more questions about experimentation in that specific case, but we can leave it off. Thank you.
Okay. More questions, snacks. You can find me on LinkedIn. We can have chat there.
Okay, thank you, Karolina. It's an amazing presentation. One more question from Jeff.
You mentioned that you have separate teams doing validation. Is that for adversary purposes, so that no leakage happens, that your team can cheat? Or what does it mean?
Yes, and it's required by financial regulators. No, it's really fun. I really enjoy that. No, honestly, I really enjoy it. Even though I'm sometimes using not the words that would express enjoyment, but I really enjoy having validation team because you build a model, then someone is validating that model the longer than you build that model. Because let's say I build one model in 1 month and then validation validated for half a year. So it's important, and you're getting approval for validation. And then I'm going to committees of financial, managers, and then I'm sitting there, and then I'm listening, and then I have to explain, and then I need to get a sign-off, and then I need to write documentations, and then I need to get additional approvals, write cover letters in simple, not simple, in complicated structures. So I really enjoy it. It's like fun. It's like a game for me.
And can I ask a follow-up question?
David, as you know. I'm fine.
No, but what is the incentive structure for the validation team to do a good job?
That's a good question, actually. Basically, we they are more actually looking not into technical details but into business things. Because if we are talking about finance, so basically bank owns money, collects money, and spends money.
So
or
it's them who gets
lends money to customers. That's a simple way how bank works. Take money, let go of money. Yeah. So yeah, they are, and it should be balanced. And basically, okay, I will tell how the banks work now. So stop me here. Basically, they are looking into the fact that bank won't lose banking license because of our models. That would be the first thing to do.
Got it. Cool. Thank you.
Yeah, thank you very much. And
Well, actually, we have 2 more questions if we have some time.
yeah, can you read it?
From YouTube
Okay.
forwards.
Oh, okay.
Jonas is asking, when you finalize your model and begin preparing it to production, should you include your test set and train it with all the available data? And the second part of the question, are there any dangers in overfitting, overconfidence, and final accuracy result?
I would say it's a quite tough question from business stakeholders. So first about test data, and could you please repeat the test data and including test data into
available data.
No.
Basically, it means that he's assuming somebody is doing that thingy. They after they found the optimal parameters that conform with it, they sort of merge everything and train on the whole data set. I saw that happen.
Okay, I didn't saw. No. So basically, if I understood that question correctly, basically test data. That's why I told the sticker, left the sticker. Forget it. It should never be merged with any kind of any data of the any data that you are using. Basically, test data. Take it, forget it, and then use it once and forget it. Yes.
So as addition to that, it's on the tutorials thing, so everybody knows about that. So in real life, you should not match test data with other data set. But in some books and tutorials, they do that.
Okay, I'm getting old. I'm now keen on those tutorials and trainings. Okay, so
Okay, thank you. We have one additional question from Alana. How do you control the model performance on prod if you don't have the right answers? In brackets, classification problem.
yeah, that's a very good question. If you don't have the right answer, then my answer would be you have to define what is acceptable answer, first of all. Because then we are entering the zone of uncertainties. And if there is no good answer, and we are working with such cases, then we are kind of fooling ourselves a bit, that we are defining what kind of answer would be acceptable. So we cannot force that, this answer should look like this or that, because then we would be cheating with our model, but then we have to have some rules, and if numbers cannot provide us the truth, then we are asking business to do that. And because, stakeholders, or whatever who's going to use. So it's not good or right, it's acceptable, not acceptable, and I don't know the concrete case, but it should be, some thresholds, what kind of answer makes me happy, or our stakeholders happy.
Thank you.
Yeah, thank you very much. And I think this is it for today. I want to also remind you that on Tuesday we have a meetup about AI papers that are nominated for AI awards for 2021. So see you then. Have a nice evening.
David, this is giving an update.
Ką? Yeah. Yeah, of course. Aš atsisveikinu.